Hello everyone, Mr. Fawcett here, and we are back with another geometry lesson. Today we're starting a new unit. It's going to mainly focus on similar triangles, but before we get to similar triangles, we have to talk about how similar triangles are created. And that's going to be through another type of transformation, dilations. So we've already talked about the three types of rigid motions. In terms of transformations, we had our rotations, reflections, and translations. Now we're going to add another transformation to that set, but you're going to notice that has some different properties. So that's why we didn't talk about it in our rigid motions unit. We are talking about it now. We're going to skip the do now. That's a review on rigid motions. So you can do that on your own, but we'll get to it in class. And we're going to jump straight into dilations. So on the left, we have a picture of a bicycle, and on the right, we have three other bicycles. So what I want you to think about is, well, if we look at this bike, which of these three is a well-scaled image of the original and why? So only one of them is well-scaled. Think about what makes it a well-scaled image. Okay, well, hopefully we understand that this one right here is the well-scaled image, and that's because in general terms, right, it still looks the same as the original bike, it's just smaller. Mathematically, we could say everything is still in proportion to the original bike. So again, if you keep everything in proportion, that's what makes it looks the same. That's what makes it look the same. If I look at, this bike, everything is kind of smushed together. It's been like compressed in. If I look at this bike, it's kind of been stretched out. So when you don't keep things in proportion, the images, or in this case the bikes, are not going to look the same. If you keep everything in proportion, they may be bigger or smaller images, but they will still have the same shape and they will still look the same as each other than the size. Let's break down dilations a little bit more. This is an example of a dilation, right? So going from this bike to this bike would be an example of a dilation. Going from this bike to this bike, or this bike to this bike, those would not be examples of dilations. And these dilations may be something you've talked about in a middle school class or a pre-algebra class. But what is a dilation? Well, it's a non-rigid transformation. It is not a rigid motion. And this is because the image has the same shape but can have a different size. For rigid transformations, right, the image and the pre-image were congruent. For non-rigid transformations, it's possible that the image has a different size and is not congruent to the pre-image. What does stay the same are the angles. So angles are preserved. So angle measurements when you perform a dilation will not change. What can change is the length of a side, right? So corresponding sides can change, but they will have the same scale factor, and we'll talk about what that is in a second. The scale factor for a dilation must be greater than 0. So let's look at the two triangles to the right. When we have a dilation, and if we were doing these dilations by hand, you would need to know what the center of dilation is right here if we were doing constructions. However, we're not going to do any of these in this class, at least not that I know of. So we don't have to worry too much about a center of dilation. What you will have to pay attention to is a scale factor, right? So if I look at this pre-image, triangle ABC, and then I look at the image, triangle DEF, well, there's some relationships regarding these sides, right? If I look at 6 and 12, if I look at 4 and 8, and if I look at 8 and 16, right? Those three corresponding sets of sides all have the same scale factor. I have multiplied each side in my pre-image by 2 to get each side in my image. And that's what they mean by scale factor, right? It's the number that you multiply every side by in your pre-image to get the side lengths in your image. And that number has to be the same for all the sides. I can't multiply one side by 2 and another side by 3. I have to multiply every side by the same number. Now, it doesn't have to be 2, it just has to be the same. All right, let's talk a little bit more about scale factors. So again, when you're performing a dilation, you do need a center of rotation and a scale factor. For our purposes in this class, though, we're going to assume that the center of dilation is at the origin, because our dilations are mainly going to be on an XY plane, and our center of dilation rather will be at the origin every time. So when this is true, to figure out where the other sides are going to be, we multiply the scale factor by each coordinate. And we'll do an example with this later on. But if we know the coordinates of the pre-image and we know the scale factor, to figure out where the new shape or the new figure, or more precisely the image, should go, we would multiply each coordinate, so each x and y coordinate, by the scale factor to get the new points. Now there's 3 options for scale factors. It can be between 0 and 1, it can be greater than 1, or it can be equal to 1. And right here, k is what we're calling the scale factor. So let's start with when k is equal to 1. So if I multiply each side by 1, will the new image be larger or smaller than the pre-image? Take some time to think. Well, if I multiply every side by 1, right, the sides aren't going to change. So the image would stay the same as the pre-image. If I multiply by a number between 0 and 1, like 1/4 or 0.5 or 5/8, think about what the image would be compared to the pre-image. Well, the image would shrink, or the figure would shrink. So the pre-image would be smaller the image would be smaller than the pre-image. Now, if you're multiplying by a number greater than 1, the opposite occurs, and the image enlarges. So the image will be larger than the pre-image. What is going on? There we go. So 3 choices for a scale factor. It can be between 0 and 1, it can be equal to 1, or it can be greater than 1. So let's do a couple of examples. So we're going to do number 1 and 2. It says use a scale factor to graph both the pre-image and the image. And number 2 says given the pre-image and the image, find the scale factor for the dilation. So I think you should actually pause the video and try to do this on your own. If you look right up above, in terms of how to figure out the coordinates for the image when you know the scale factor and where the pre-image is located, you may be able, again, just look up above to figure out the connection between that. So I will go through these, but again, try to work them out on your own. If you're able to do both of these, then you have pretty much mastered the idea behind this lesson. So go ahead on your own first, and then come back and see if you did it correctly. Okay, so the first thing I'm going to do is graph the pre-image. So -6, 4, -4, 0, -1, 2. So we do have a triangle here. We will label these with their points, so A, B, and C. Now you remember from up above it says when our center of dilation is at the origin, which you can assume here, because like I said, every dilation we do in this class pretty much will have the center of dilation at the origin. To find the new coordinates, you just multiply the old ones by the scale factor. So A is at negative 6 comma 4. A prime, well, we're just going to multiply by 1/2. So A prime becomes negative 3 comma 2. That's A prime. Do the same thing for B. So B, negative 4 comma 0. B prime, if I multiply by 1/2, I'm going to get negative 2 comma 0. And finally for C and C prime, if I multiply by 1/2, I get negative 1/2 or negative 0.5 comma 1. Negative 0.5 comma 1. Looks like it'll go right there. And there is my image, A prime, B prime, C prime. And remember, right, our scale factor is between 0 and 1, so our image should be smaller. And our green image is certainly smaller than our pre-image in red. Number 2 says, given the pre-image and the image, find the scale factor. So we already know the coordinates of the pre-image and image. So if we compare those coordinates, we should be able to figure out what the scale factor is. Now we just need to make sure we go the correct direction. So if I look at A, A is located at negative 3 comma 2, and A prime is located at negative 9 comma 6. So what does it look like I'm multiplying by to go from A to A prime? Well, I think it's pretty easy to see that we're multiplying by 3. Now, do we need to check the other points? Right? If we were trying to figure out whether this was a dilation, yes. However, it tells us it's a dilation, so we know that the scale factor has to be the same for the other points. So if it's 3 for A and A prime, it's got to be 3 for B and B prime, and C and C prime. So I actually don't need to check the other points here because I know it has to be the same. So if I find it for one, I found it for all. And my scale factor here again would be 3. Now, sometimes you're not going to get a nice whole number for your scale factor, right? It might be a decimal, it might be a fraction. So there's another way that we can do this. Because let me give you an example, right? Let's say I don't want to erase everything. I'm actually going to go to a completely new page so I don't confuse you. So I am going to erase everything. So let's say I don't even give you a graph, right? Let's just say I give you some points. So I say A is located at 4 and 10. And I say A prime is located at 5 and 12. Sorry, 5 and 12.5. That would work. Well, it may not be obvious to you what the K value is here, what the scale. Why is this not working for me? It may not be obvious what the K is. So, and that's because it's not a whole number. Or I guess it has to be a natural number, right? It can't be 0. So the way we figure out the scale factor is we can set up a ratio. So scale factor, and we'll talk about this more in later lessons, but I might as well introduce it to you now. Scale factor is going to be equal to the image. Man, I cannot spell today. Image over the pre-image. So if I set up that ratio, if I set up an image coordinate, which is 5, over a pre-image corresponding coordinate, right? So I'm going to use the x coordinate, which is 4. This is my scale factor, 5/4, or that's also 1.25. Either one would be acceptable here because the decimal terminates. If it was a repeating decimal or a terminating decimal, then you would just leave it as a fraction. But if I multiply 4 by 5/4, right, that gives me 20/4, which gives me 5, which is my a prime x value. And if I do it with my y value, right, 10 times 5/4, that gives me 50/4, which gives me 12.5, which is my other a prime value. So again, this relationship right here is going to be key for figuring out the scale factor when it's not an easy number to identify. We just have to remember it's image over pre-image. And let's say you forget that it's image over pre-image and you do it the opposite way. And I just deleted some of this stuff to make it a little less cluttered. But let's say you said that k was equal to 4/5. Well, when you look at your pre-image to image, right, you know that you have to multiply by something greater than 1, right, because you're going from 4 to 5, so you have to increase, and 10 to 12.5, so you have to increase. So again, that k value has to be greater than 1. But the one you came up with, 4/5, is less than 1. So that should immediately set off some alarm bells to maybe, make you go back and think, okay, did I use the correct ratio? Did I do image over pre-image or pre-image over image? So again, even if you forget this, which way it is, as long as you do it, as long as you remember it's either image over pre-image or pre-image over image, you can kind of figure out which way it has to be based on whether it's supposed to be greater than 1 or less than 1, based on the numbers or the sides that you have. Okay, so again, intuitively, we could figure out that 4/5 is not correct because we need a number greater than 1. Again, we'll do more practice with this in later lessons. This was just a little bit of an intro to dilations. And we are going to stop there. So moving forward, we'll start talking about how we use dilations and how they factor into similar triangles. Until then, enjoy the rest of your day, and we'll look forward to seeing you next time.